Hi everybody, I'm here to talk to you about section 3.5 in your book, Derivatives of the Trigonometric Functions. And I'm start off here by finding the derivative of sine x. So if we want to find the derivative of the sine of x, we're going to have to apply a limit here, right? A limit definition of a derivative as h approaches 0. And that would be, remember, we're doing the definition. So it's the function at x plus h minus the function value, there we go, over h. So when we plug those in, we're getting sine of x plus h minus sine x all over h. And I don't know if you remember these or not, but there were some things, sum and difference formulas to help us handle expanding the sine of two angles summed, x plus h. And if you expand it, if you don't, I'm going to suggest that maybe you should just remember these. And then I'm going to put the minus the sine x. And that is ultimately my goal. Some things just have to fall out of your mouth or out of your pencil on the AP exam, and the derivative of sine is going to be one of those things. Now I'm going to group this one and factor out a sine x, only because I know where this is going. And that's going to leave me with cosine h and minus 1. And this is all going to be over h, right? Now remember, if I put this over 1 and multiply them, I'm going to get that. And then I'm going to go ahead and leave this cosine h, sine h. I'm just going to, sorry, cosine x, sine h. I'm just going to write it sort of in a different way. It's also over h. So if I were to multiply these back out and get them over a common denominator, we'll be right back where we were. Now, the reason I did it this way is because that's an identity as h approaches 0 that we talked about the other day. So if I plug in a value as h goes to 0, this is actually 0, which gives us sine x times 0 is 0, right? And then I also know, we talked about this one in our limits chapter, the limit as we approach 0 of sine h over h. And you can put that in your calculator, sine x over x. You can see what it's going to as approach 0. But like I'm about to tell you right now, it's 1. And what all that did for us was we found out that the derivative of sine x is cosine x. Now there's by far better ways. That's our first one. Yay, 1 down, 5 to go. All right, so the other way we could have done that, and the reason I show you that is because I encourage you to memorize these things. And if you don't, you're just going to be stuck doing stuff like that. And I don't know that that's what you want to do. So the other way we could have done this was I could have gone ahead and had you graph the derivative of the sine of x and graph it for all x. And I'm going to go ahead and see what my Windows settings are. I don't want that. I want to go negative, maybe 2 pi to 2 pi. And I certainly don't need a y from negative 10 to 10 when I'm doing sine, which I know goes from negative 1 to 1 on the range there, and I can graph that. Okay, and now it's taken a while to graph because it's calculating out the derivative at every value. All that considered, it's actually doing pretty well, huh? And I was just going to maybe have you look at that graph. Doesn't that actually look like the cosine graph? And it really does, right? So the derivative of sine is cosine. If you ever forget it, you can graph it. Instead of go through everything that I went through algebraically. Now, let's then go ahead and take a look at, for our next one, and I'm just going to write it up here. I'm not doing this one algebraically. That about wore me out. Let's go ahead and find the derivative of cosine x, and that'll be our second one. Go ahead, you go on your calculator, and we'll graph it. And if some of you are guessing that it's sine x, I want you to look really close at this. It sure looks sine-like, but there is one difference. And if you're not sure what the difference is yet, if it's not hitting you in the face, I'm going to go to y equals, and on my second one, I'm actually going to graph the sign so that you can totally see exactly the difference. So the blue is our derivative. It's not quite the graph of sine, but it's the graph of sine reflected, negative sine x. That's our second. See, only 4 to go. Not too bad, right? Okay, so the derivative of sine is cosine. The derivative of cosine is negative sine. Let's take a quick look at the derivative of the tangent of x. I'd like you to pause me and try to think about some approaches to this. Just think of how you could do this problem. So go ahead and pause me and give it some thought. All right, well, I have no idea what the derivative of tangent x is. If I did, I wouldn't be in this situation. So I'm going to go ahead and make kind of a note to myself that I know that tangent is just the sine of x over the cosine of x. And that's actually a quotient. So when I'm taking the derivative, I see no reason why I couldn't use the quotient rule because I just figured out what the derivative of sine and the derivative of cosine were. So we're going to go ahead for this derivative and take low, and then the derivative of sine was cosine d high minus high, which is sine, times the derivative of cosine, which was negative sine. And then square the bottom, and away we go, right? Alrighty. And then if we simplify this a little, I'm getting cosine squared x plus sine squared x, which is one of our real famous identities there, the Pythagorean. So that just comes out to be 1 over cosine squared x, which is otherwise known from its reciprocal identity as secant squared x. So now we real nicely have the derivative of tangent is secant squared x. And now we never have to go through that again. We're going to memorize that. Some things should be memorized in AP Calc. And by a similar method that I don't want to drag you through the mud on this, but similarly, if you use the same type of method of making it a quotient, only this time it'd be cosine over sine, we can find the derivative of cotangent of x. And you'll find that it involves a cosecant squared and that it's negative. You don't have to believe me. You can go through and give that a shot. Okay, let's go ahead and look at one more. Let's go ahead and find, what do we have left? Secant. Let's go ahead and do that. The derivative of the secant. Now pause me and take a thought, think a little about a process you could use to try to do this, and then go ahead and do it. Okay, if I knew what the derivative of secant was, I'd be done. I don't, so I'm going to have to get resourceful and rewrite it with its reciprocal identity. And then I'm going to go ahead and use that quotient rule again. So we're going to get low, and the derivative of 1 is 0. So low d high minus high. Derivative of cosine is negative sine. And then square the bottom, and away we go. And when we simplify that, we're just getting sine x over cosine squared x. And I'm going to do something kind of weird and split this up because there's a very traditional format that we put this in. We don't leave it as sine x cosine squared x. We can kind of rewrite this as 1 over cosine x times sine x over cosine x, right? It's the same thing. If you multiply it, we get sine over cosine squared. But this is the definition that the AP exam in your book would typically use for the derivative of a secant. 1 over cosine is secant, and then this is tangent. So secant x times tangent x. And that actually is the derivative of secant. And you may actually be able to guess the derivative of the cosecant by a similar process. It is going to involve not a secant, but a cosecant, and not a tangent, but a cotangent. And of course, like all the cofunctions, it's going to be negative. Right? So if you look at our first one, derivative of sine is cosine, derivative of the cofunction is negative. Then we went to the tangent, same idea, derivative of the tangent was secant squared, derivative of the cotangent was negative, cosecant squared. And then of course the ones that we just completed right now. All right, folks, thanks.